In this example, we're going to look at cars that are moving perpendicular to each other. And we're going to ask at what rate the distance between the car is changing, or what is for instance, the relative velocity between the two cars. So let's say one car is traveling west at a certain velocity, the other car is driving north, and they're both heading toward the same intersection. So you can imagine that if they are heading to the same intersection, the distance between them is diminishing, and so is the relative velocity between them. And that will be the question, at what rate the cars are approaching each other. All right, so let's write it. Car A is traveling west at 50 miles per hour. Okay, car B is traveling north at 60 miles per hour. Both cars are headed for the intersection of the two roads. Okay. So, at what rate are the cars approaching each other? Okay, when car A is 0.3 miles from the intersection, car B is 0.4 miles from the intersection. So when car A is 0.3 miles and car B is 0.4 miles. I forgot to put a question mark at the end of the previous question. So this is the, again, long problem to write. Let's see if we can visualize. It's really difficult to do these sorts of problems without a good sketch. So, and in this case, we're talking about also the compass direction. So, let's see. The north is up. That's usually how we describe the north. And I wonder if people in the southern hemisphere do the same thing. Or they point south on top. I haven't been to the southern hemisphere yet, so I don't know how they do it. Anybody been there? South of the equator? Anyway, car A is driving west. Well, to the right of the north is east. So east is in this direction, and the east direction would be x, and the north direction would be y. Okay? And let's say this is our car A, and so let's put A here, and A is moving in this direction at 50 miles per hour. So what would be dx dt? Do tell me. It would be negative 50 miles per hour. Okay? And the distance at a certain point will be 0.3, so we can write x equals 0.3 miles. At the same time, car B, and let's say this is car B right there, it's heading north, and so we have dy dt, and dy dt, since it's heading north and all north in our system, coincide with the y direction, so it will be positive 60 miles per hour. And this distance is 0.4. Is it positive or negative 0.4? Y equals what?
It's got to be a positive distance because we're talking about both things.
If this is the origin, it's got to be negative. Okay, remember, we are operating with this coordinate system, with the standard Cartesian coordinate system. So the car is heading north toward an intersection, so the car is south of the intersection, therefore the distance is considered to be negative. Okay? The distance between the two cars is this diagonal, which is really the hypotenuse of the right triangle. Okay? So this will be d, the distance, and what we need to find is, and here I'm gonna say it and it sounds funny, we need to find dd dt, like so. Okay? dd dt. One question for you. In anticipation of the result, if I'm getting a result that is, let's say, positive 35 miles per hour, can you tell me right off the bat, without calculation, whether my result is correct or not? Or does it make sense? Does it make sense to, if you drive 50 miles per hour west, 60 miles per hour north, that the relative velocity will be positive 35 miles per hour? Why not?
It should be a number closer to both and greater. Maybe less than 60.
Disagree with you. I agree with the no part. I disagree with the explanation. There is a much stronger explanation. You got half of it correct. But why the answer 35 miles per hour cannot be correct? And it has nothing to do with the size or the magnitude or the value of the speed. It has to do with the sign. Since the distance is diminishing, the velocity has to be negative. Okay, if the distance is increasing, then dy dt will be positive. Because the distance is decreasing, this has to be negative. So if you calculate and you end up having a positive result, throw away the answer. That's the idea behind it. So sometimes you need to have your common sense supervise your calculation. And that will be the ultimate decision whether you obtain the right answer or not. All right. So now we need to go into the actual nuts and bolts of the solution. Well, first of all, let's set it up. So we know by the Pythagorean theorem that x squared plus y squared equals d squared. Okay? So what we can do at this point is take the derivative and say d dt, again, implicit differentiation of x squared plus y squared equal d squared will produce the following. 2x dx dt plus 2y dy dt equals 2d dd dt. So here we have three relative rates. dx dt, dy dt, dd dt. We know dx dt, we know dy dt. We also know x and y. We need to find the dt. What's missing is the d itself. Okay. So before we go and look for d, what we can do, we first divide everything by 2 throw away the 2, so we have x dx dt plus y dy dt equals d dd dt, and eventually dd dt equals 1 over d times x dx dt plus y dy dt. So we solve for the dt, except you don't know what's d right now, but this is easy fixing because d itself is the square root of x squared plus y squared, and we have those values. So x squared is 0.3 squared, y is negative 0. Let's write it negative 0.4 squared. It doesn't matter because it will come positive. So let's say 0.09 and 0.016 is 0.25. So this becomes 0.5 miles. So the distance at this point where x is 0.3, y is negative 0.4, the distance would be half a mile at this point. Okay? And now we are ready to calculate the whole thing. So go back and put the values in the equation on top, and it will be 1 over 0.5. Well, that will be 2. And then plug in. So we have 0.3 times dx dt. Well, that will be negative 50, if you remember, because we're heading west and east is the positive direction, plus y, which is negative 0.4, times dy dt, which is positive 60, and let's calculate. So let's see, we have negative 15 and negative 24. So that would be negative 39 times 2, that would be negative 78.